I'm going to quickly kind of go through logistic regression. I'm not going to go through the whole parts of it just because this would take another 40 minutes at least, go through the whole part. But basically, just know from logistic regression, it's derived from linear regression. And basically what you'll see in a logistic curve is, oops, undo, okay. A logistic curve. So like with a linear regression, we'll have like points, right? And then we'll kind of find a line that fits between those points. This is 2 dimensions, right? Nothing too fancy or too complicated. And so that's kind of a linear regression. Well, a logistic regression basically is that you tend to have points either at a yes or a no, okay? Meaning that it's kind of like a true or false, a binary decision. And here might be another feature, So a classic example is like, okay, let's imagine this is, for example, our weight, okay? And let's say this is yes or no for heart disease. So this is like, no heart disease, your heart is good. And this has heart disease. Okay, so these are kind of our 2 classifications. And our points, like, well, some people who are very, very low weight, they tend to, let's say most people with low weight will tend to have, when we measure it, have no heart disease. Maybe there's a couple people who do, right, have heart disease, but they have a low weight. And then people who are higher weight, there are some people who have healthy hearts, even though they're like, maybe they're more muscular or something like that. That's why they have a higher weight, or maybe they're just taller, right? But sometimes, let's say like, when we see on the extreme end, we definitely see a lot of more heart disease, even people over here. And then people are in the middle, maybe it's like sometimes here, sometimes here. So this is kind of like how we would say, okay, this is kind of like yes or no based on our weight, right? And so what we do with logistic regression, just like how we wrote a line and best fit, we'll actually make a logistic curve. And this logistic curve basically will look something like this. Okay. And what this is supposed to predict is basically say, okay, give a weight, given this weight right here, do they have heart disease or not? And this actually gives a probability of saying, like, oh, they have heart disease. And it's like, like if they're around this weight, it's like, oh, they're close to like 99% likely to have heart disease. And on the far end over here, it's like, well, if you are very low weight, you are very unlikely. Let's say it's like, oh, look, only like 3% at this weight, you would have heart disease, based on this logistic curve, right? And you can see here that sometimes it matches really well, like these points right here. Other times, right here, it matches really well. But there's some points like right here and over here, it doesn't do too well. And maybe over here, it's like, well, it kind of did it pretty well. Basically, if you're falling within this area, this kind of represents saying, okay, you're 50%, right? Or, not exactly sure. And so the logistic regression, basically we scale from going from 0 to 1. 1 meaning that's like, oh, you definitely have heart disease. 0, you mean you don't have heart disease, right? Your heart's good, okay? And then in between here would be represent probability, right? So the idea here, and what's kind of interesting, if you look at the logistic curve, which is this equation right here, you'll find that you can never quite reach 0 and you can never quite reach 1. You'll always approach 0 and 1 as you increase and decrease, smaller and smaller or bigger and bigger for your feature. So the idea here is like you're never 100% sure, right? And this kind of matches really well. So this is other classification. So there's other ways we can do classification. This is kind of like I like to say, like the beginner level, like it's kind of like introduction to classification because we use our linear regression here. But anyway, this is our logistic regression. And just to kind of show how this is implemented, I'd go into more detail, but I want to make sure we get to the other parts of classification. But this is basically built with sklearn, which we'll see over and over again. You'll see basically I'm importing this specific model, kind of like how we did with linear regression. And I'm just getting a data set from that's built into sklearn called Iris. Basically, it's about flowers. It doesn't really matter what it is. It's just kind of like showing what it is, or like, just some random data set. You can see it's 150 data points in here. So it's not that big, but you can see like, okay, let me go ahead and run this. And I'm not going to go through the whole thing. We'll go over this maybe another time. But you can see really quickly is how well it does. So I actually run the logistic regression and basically note that I kind of had here really quickly is I'm looking at the classification. Sorry. Oh, is it just 0 and 1? I can't remember now. I can't remember if there's just 2 targets. Okay, anyway, it basically is trying to say, okay, oh no, I'm just looking at 1 target. So I'm looking at 1 target, it's like, okay, how many of those targets like did we predict to be true? and false based on those features. Say, oh, okay, well, we actually got 117 out of 120 correct. And you can see about a 97%, of them are correctly predicted, right? And that's just for the training set. So our testing probably is not going to do as well as our training set. And we can see here, we actually have about 28 out of 30, which is still pretty good considering we only have 3 wrong here. And that ends up being about 93% were correctly identified. So this is kind of like how you can see it's not that large of a thing, but if we went over it, we could talk about different parts. But we're going to move on to this. So we can see oh, we can now make classification. So the one problem with this is that it's nice to be able to see oh, 93% were guessed correctly. But then you can start having other things well, how many of those, we got some wrong. It's but what did we get wrong? Did we get that? Did we think ones that were a yes were actually a no? Or do we think a no was actually a yes? Because those could be very different, right? And those might matter. For example, for heart disease, if you identify someone who's I deleted it. But if you imagine on your classification, you imagine someone who's I think you don't have heart disease. Oh no, you don't have heart disease, but they do. Well, that could have potentially caused harm. Maybe, for example, you misdiagnosed it. Oh, you don't have heart disease, off this metric, you're underweight, you're pretty good, and they do have heart disease. Oh, you could get a medicine prevented that stuff. Versus someone's you said you do have heart disease, or you think you're likely to have heart disease, because you're under these parts, but they don't have heart disease. That debatably is maybe a lesser harm. It's well, it's more important to catch someone who does have heart disease than it is to misidentify someone who doesn't have heart disease as heart disease. So you can kind of imagine that's a different kind of harm, but you can imagine okay, we want to make sure we catch everyone who does have heart disease. And this is what brings us into our different evaluation. And the way we do this is through something called true false positives. Okay. And this is where you have specificity and precision and accuracy. So all these different parts.